I didn't expect that there were superconductors on the Earth, and human beings had long discovered that substances such as copper and iron can conduct electricity. And the resistance to electricity passing through these conductors was very small, that is, the resistance was very small. And later they found that the insulation and resistance of wood and stone were very large, and it was not easy to conduct electricity. And then they found that semiconductors between conductors and non-conductors, such as the conductivity of the congener, would follow the temperature increase. But I'm afraid people never thought of it before, and the discovery of superconductors was a complete accident. We all know that the boiling point of water is 100 degrees, that is, when the temperature exceeds 100 degrees, water will change from liquid to gas, and in turn. When the temperature of water vapor is less than 100 degrees, it will be liquefied, and similar other gases will be liquefied at a certain temperature. For example, oxygen will drop to minus 182.95 degrees, and it will become liquid. Find out the boiling point of various gases, and liquefaction of various gases, which used to be an important research topic in physics. And the famous master of liquefaction gas named Michael Faraday is not only the father of electricity, but also succeeded in liquefying chlorine and ammonia gas in 1923. These two gases can be liquefied at minus 30 degrees, but many collectives were considered permanent collectives at that time, such as hydrogen and oxygen. Could not be liquefied until 1989, when Dutch physicist Unless succeeded in liquefying hydrogen because the boiling point of hydrogen gas was as low as minus 252.87 degrees Celsius. And then similar achievements marked the success of human beings in liquefying almost all gases. Only the last challenge was left. Egypt, the lowest temperature in our universe is minus 273.15 degrees Celsius, that is, absolute zero, and then reduce the temperature to only about 10 degrees higher than absolute zero. Other gases are liquefied, that is, helium is always stubborn, so how to achieve lower temperature? How to liquefy helium became an extremely important competition for scientists all over the world at that time until 10 years after the liquefaction of hydrogen. It was 10 years later. July 10, 1908, it was still unnecessary. This person known as Mr. Absolute Dew, who kept approaching the lowest temperature in the universe, finally succeeded in liquefying the last helium-7. And he found that he remembered that the boiling point was only 4.2 degrees higher than absolute zero, that is minus 268.93 degrees Celsius. Similarly, because of the liquefaction of helium and its many contributions to ultra-low temperature physics, I won the Nobel Prize in Physics in 1933. And the similar goal was not only to win the lower temperature, but also to study the characteristics of other substances in the greenhouse space, such as the change of resistance of metal substances at very low temperature. There were two opposing views at that time. One was that the resistance of metal would approach zero at very low temperature, and the other was that it would increase infinitely. Who was right? It can only be proved by experimental results that unless was found to be highly pure mercury at very low temperature one day in April 1911. And it would show some strange phenomena when the temperature was between 4.21 and 4.19 K. The resistance of mercury would drop sharply, and at 4.19, the resistance would even disappear completely, showing a state of zero resistance, which at first seemed to be similar to that. This was only a unique feature of mercury, until later it was found that dilute and lead were found again at very low temperature, and the general significance of this phenomenon was found in this very special physical state. It was called by the lace name Rn. Superconductivity was only discovered this time in conductors, insulators, and semiconductors, and people found superconductors, although they could not explain the draft at that time.